Welcome to Manasi Solutions. Today we are going to discuss a problem from previous year question paper of CSIRNet. So let's start. First of all, consider the question. The question is that the equation 11 raised to x plus 13 raised to x plus 17 raised to x minus 19 raised to x is equal to 0 has the first option is that no real root, second one is that only one real root, and the third one is exactly two real roots. The fourth one is more than two real roots. Okay, here we need to find the true options. Okay, consider the equation 11 raised to x plus 13 raised to x plus 17 raised to x minus 19 raised to x is equal to 0. And divide this equation by 19 raised to x. Then 11 by 19 raised to x plus 18 by 19 raised to x plus 17 by 19 raised to x minus 1 is equal to 0. Now consider the LHS of this equation and let f of x is equal to 11 by 19 raised to x plus 13 by 19 raised to x plus 17 by 19 raised to x minus 1. Then the zeros of this function will be the roots of this equation. Here these two equations are equivalent. So they have the same roots, and the roots of this equation will be the zeros of this function. So let's discuss about the zeros of this function. Now look at this function, in which consider the expression 11 by 19 raised to x and 13 by 19 raised to x and 17 by 19 raised to x. If x not equal to y, then we can say that 11 by 19 raised to x is not equal to 11 by 19 raised to y. This is true. Also, 13 by 19 raised to x is not equal to 13 by 19 raised to y. In the same way, 17 by 19 raised to x is not equal to 17 by 19 raised to y. So we can say that if x not equal to y, then all of these terms are distinct. So we can say that f of x is not equal to f of y, because f of x is the summation of these terms, and f of y is the summation of these terms. Since x not equal to y, these powers will be different, which means f of x is not equal to f of y. That is, if x not equal to y, then f of x is not equal to f of y, which means f is a 1-1 function. So here f is a 1-1 function. And now look at the function f of x. Here 11 by 19 raised to x, 13 by 19 raised to x, 17 by 19 raised to x, all of these are continuous. So f of x is also continuous. So we can say that f is a continuous function. Continuous function, and which is 1-1 also. We know that if a function from R to R is continuous and 1-1, then either it will be a strictly increasing function or it will be a strictly decreasing function. Now we are going to check that whether this function is strictly increasing or it is strictly decreasing. For that, here f of x is equal to 11 by 19 raised to x plus 13 by 19 raised to x plus 17 by 19 raised to x minus 1. And now look at 11 by 19, 13 by 19, 17 by 19. All these are positive numbers which is less than 1. So when we consider the powers as x tending to infinity, the powers also, all of these terms will tends to 0. So f of x tends to minus 1 when x tends to infinity. Okay, now again look at the expression 11 by 19 raised to x, 18 by 19 raised to x, 17 by 19 raised to x. As x tending to minus infinity, all of these terms will tend to infinity. So we can say that f of x tends to infinity as x tending to minus infinity. Now look at these two statements. From these two statements, we have f of x is a strictly decreasing function, and already we proved that f is continuous and f is 1 and here we got f is a strictly decreasing function and its lower bound is minus 1. So there exists a unique element x, unique real number x, such that f of x is equal to 0. Okay, which means there exists a unique real number x such that f of x equal to 0, which means there exists a unique real number, real root x for this equation. So option 2 is the right answer. Option 2 is the right answer. Okay, answer the question. Here we need to find the sum of this series, which is a series 1 by 1 factorial, 1 by 1 factorial plus 1 plus 2 by 2 factorial plus 1 plus 2 plus 3 by 3 factorial plus etc. Here we need to find the sum of this series. What are the options? The first option is that e, the second option is a by 2, and the third option is 3a by 2, and the fourth one is 1 plus e by 2. Now look at the series. Here the nth term is equal to, the first term is that 1 by 1 factorial. The second term is that 1 plus 2 by 2 factorial. Now look at the third term, which is 1 plus 2 plus 3 by 3 factorial. So the nth term will be 1 plus 2 plus 3 plus etc. Look, here the second term is 1 plus 2. Third term is 1 plus 2 plus 3. So the nth term will be 1 plus 2 plus 3 plus etc. plus n by n factorial. This is the nth term. Now, the sum of first n natural number is that n into n plus 1 by 2. So here, write n into n plus 1 by 2 all divided by n factorial, which is equal to 1 by 2 into n plus 1 by n factorial. And we know that n factorial is equal to n into n minus 1 factorial. So here, which is equal to n into n plus 1 by n into n minus 1 factorial. We can cancel these two n, then we get 1 by 2 into n plus 1 by n minus 1 factorial. Okay, which is equal to 1 by 2 into, consider the numerator of this term. Here I am subtracting 1 from this expression, then adding this term by 1. Then the result, the net change will be 0. Minus 1 plus 1 equal to 0. So I can write this as n minus 1 plus 1 plus 1 by n minus 1 factorial. Okay, which is equal to 1 by 2 into n minus 1. Here n minus 1 plus 2. Here 1 plus 1 is equal to, here 1 plus 1 is equal to 2. So which is equal to 1 by 2 into n minus 1 by n minus 1 factorial plus 2 by n minus 1 factorial. Okay. Again, n minus 1 factorial is equal to n minus 2 factorial into n minus 1. So n minus 1 by n minus 1 factorial is equal to n minus 1 by n minus 1 into n minus 2 factorial, which is equal to, we can cancel n minus 1 from the denominator and numerator, then we get 1 by n minus 2 factorial. So here which is equal to 1 by 2 into 1 by 2 into 1 by n minus 2 factorial plus 1 by 2 into 2 by n minus 1 factorial. Here we can cancel this 2 and this 2, then we get 1. 1 by n minus 1 factorial. Okay. And here a n is equal to 1 by 2 into 1 by n minus 2 factorial plus 1 by n minus 1 factorial. and it is defined for n greater than or equal to 2. Here n minus 2 factorial is defined for n greater than or equal to 2. So the summation over n, a n is equal to a1 plus summation n equal to 2 to infinity a n, and which is equal to a1. a1 is that 1 by 1 factor, which is equal to 1. So 1 plus summation over n equal to 2 to infinity 1 by 2 into 1 by n minus 2 factorial plus 1 by n minus 1 factorial, and which is equal to 1 plus 1 by 2 into summation n equal to 2 to infinity 1 by n minus 2 factorial plus summation n equal to 2 to infinity 1 by n minus 1 factorial, and which is equal to 1 plus 1 by 2 into 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus etc. plus 1 by 1 factorial plus 1 by 2 factorial plus etc. And which is equal to 1 plus 1 by 2 into, we know that E is equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus etc. So here this expression will be this series will be equal to E. Okay, plus here E is equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus etc. Then E minus 1 is equal to what? 1 by 1 factorial plus 1 by 2 factorial plus etc. So this series will be equal to E minus 1. So it is E minus 1. So in total, which is equal to 1 plus 1 by 2E plus E minus 1. Here 1 minus 1 is equal to 0, and 1 by 2 plus 1 by 2 E plus A is equal to 3 by 2 into E. So the summation of the series is equal to 3E by 2. So the third one is the answer. Okay.